Hi, everyone. My name is Lois Curfman McInnes, and I am speaking to some of the developers of the PETSc software library to talk about issues related to software teams. We're speaking as part of the Collegeville Workshop for Scientific Software in 2021. So welcome. And first of all, Barry, could you tell us about your experience working with software teams, a little bit about the team, what you work on, what kind of products the team develops?
Hi, I'm Barry Smith. I've been working on variants of PETSc for over 30 years now, first in a two-person operation that has grown now to a large community of contributors and active users who engage with the community on many of the development issues and usage issues of PETSc. We're a distributed team without a real formal organizational structure, whose focus is on developing essentially one set of libraries, the PETSc libraries for scalable solvers, for algebraic systems, and all the related infrastructure for simulating problems with PDE models, ODE models, performing optimizations on these models, and so forth.
Thanks. Are there aspects of this team that might be considered unusual in any way? Matt, do you have thoughts about that?
Hi. Yeah, for the small kind of team that we are compared to something like Apache, we are widely geographically distributed. We have people in lots of different countries, lots of different time zones. And they work in different places. So we have people in government labs, people in industry, people in academia. And one of the, I think, most interesting aspects is that unlike some other DOE software efforts, most of the people in the PETSc team do not depend on PETSc proper for funding or for Argonne for employment. They are kind of working toward their own goals and using PETSc in different ways and promoting different aspects of it to get their job done.
That's a really good point. And so that might be a nice segue into introducing Matt a little more completely. So this is Matt Knepley, who's been a longtime PETSc developer. Matt, can you tell us a little bit about your history?
I worked in the summer for Argonne as a student, which convinced me to go back and work there as an employee for 8 years. And it was really great. And then when I left, I went in first to be a research scientist and then go into academia. So now I work at the University of Buffalo.
Thanks a lot, Matt. Jed, would you like to comment more about the community issues?
Sure. So the trick here is really to create the infrastructure in the community so that when you have a bunch of different people working towards their individual goals, and those goals in general are not PETSc goals specifically, but you want to make it so the most efficient way for them to get that done is by making technical and social contributions to PETSc. And that's the maintainer challenge, and there's a lot of legwork in doing that and a lot of communication, but it's really rewarding because you end up with a large team that's creating mutually useful value.
Thanks so much. Yes, that is indeed true. So Richard, do you have comments? I know you've been working with the team for quite some time.
Yeah, let me introduce myself very briefly. I'm Richard Mills. I started working with PETSc as a serious user in 2003 when I was doing a fellowship practicum at Los Alamos National Laboratory and developing a subsurface hydrology and reactive transport code called pFlowTran that's built entirely on top of PETSc. So I became a serious user of PETSc in 2003. A few years later, as a young staff member at Oak Ridge National Lab, I started doing a bit of work actually contributing to PETSc itself. After 10 years at Oak Ridge National Lab, I actually ended up in the computer industry for a while and spent close to 4 years at Intel Corporation, where I ended up doing a fair amount of work on PETSc targeting Intel CPU architectures while working for Intel. I actually work for Argonne now, and am currently on some actually very explicitly kind of PETSc projects. But most of my time working with PETSc and developing on PETSc has not been through official PETSc funding, and it was really just as part of accomplishing some science goal that we needed PETSc for that I worked on that. And I just think that there are a lot of people like me who've ended up contributing to PETSc through that route. And a real strength of the PETSc community is how good I think it is at drawing in people using PETSc who are really just trying to advance their science goals. But we turn this into developments back into the PETSc community that really improve PETSc.
Thanks, Richard. That's a really interesting way to look at the connections between multiple teams. Barry, could you comment on some of the challenges that the team has recently faced and are dealing with now?
I would say the largest challenge that a bottom-up team community like PETSc faces is how to organize a relatively large number of people on a particular topic. So in particular, recently, this has been support for GPUs for the DOE exascale computing program, where everybody's interests may lie in various directions, some with regards to GPUs, some with little interest in GPUs, in organizing everyone effectively to be able to tackle the problem is not always straightforward, since we cannot just simply offer either a carrot of funding for everybody or a stick of not funding for everybody, since people really are working with PETSc and in the PETSc community because of their own interests in it, and are not really driven very much by carrots and sticks. It's also difficult to for the community to sort of recognize that there may be a paradigm shift and adjust for that paradigm shift. And as time goes by, for example, with the increased interest in mixing machine learning with simulation, again, how recognizing how that can be done and organizing the community to take that into account and develop an infrastructure for that is perhaps a little simpler in a top-down organization. But I think that the bottom-up organization allows allows for a lot more creativity and impact by individuals who really care about the topic.
Barry, do you think the GPU thing is hard because it touches a lot of the library? In my view, like the ML thing is easier because it can be, somebody working alone and you can kind of graft it in. But the GPU stuff is forcing rewrites in a bunch of places that hit everything.
Yes, Amdahl's law definitely applies in this situation. And one can't say, oh, well, we'll simply parallelize the solvers and then we won't have to worry about GPUs. We can separate that concern out from the other parts. But the reality is that you have to look at everything with respect to GPUs, or you're going to lose really the benefits of using GPUs. So it is a case where it's quite a paradigm shift in a level that affects almost everything.
Richard, do you have any additional comments? I know you've been working in this area recently.
Well, I'd like to back up just a little bit and just note, as Barry and others have pointed out, PETSc doesn't really have a top-down infrastructure like some other scientific computing projects do. Ours is very much a more bottom-up kind of grassroots thing, where a lot of these, if you move PETSc in the direction of some paradigm shift, it can't happen by fiat, right? It has to happen in this organic way, where somehow enough people work together, maybe in a small group on PETSc, and they finally come with, hey, we have a great way to address this this GPU paradigm, for instance, and then get they somehow have to like reach critical mass to get buy-in from the other PETSc developers, and it can be hard, especially with something like the the GPU stuff, as Matt was referring to. It really just requires like touching a whole lot of PETSc and not just adding code, but kind of re-architecting parts of it. So I don't really have a good example. I don't have good thoughts on how to kind of make this process go more smoothly. I just wanted to point out it's something that doesn't just happen easily or overnight by fiat. You can't just say, well, DOE says we really need to do this, so we're going to do this. It doesn't really work that way. Looks like Matt has something to say.
I think the last time we had a major decision like that was when we decided to move to Git from our old version control, and that took months of wrangling and many emails, and people like myself were eventually only convinced because it was so much faster than what we were doing, right? And I think that's what's good about it, is that people just don't take your word for it. They have to see that there is usefulness when we decide to do some. I guess you could also say when we decided to do continuous integration, but there was much less pushback. There was just some skeptical, people about, how much benefit there would be. It turned out to be a lot more benefit than was advertised.
Yeah, and I'd say I think the PETSc community really exemplifies this term I've heard people talk about, like constructive confrontation. Like I think actually we eventually get more buy-in from the PETSc community because things like the move to Git involve so much sometimes rancorous debate, but everybody gets to have their say and kind of hash out things and try to convince people. And I think when sort of a decision point really is reached, like people can even if they didn't buy into that decision initially, they understand, like why the community is moving towards doing that. And I think that's a big benefit, rather than just having a few people in charge say, we will do X, without really, kind of vetting it through the sort of peer review, I guess, that happens with all the debate on things like the user and developer forums about these changes.
Thanks. Are there any other areas of challenges, Barry, that you want to mention?
I would say another area is getting enough people interested and devoted to what might be considered the boring parts of the code. That is, for example, the configuration code, which is crucial to the success of PETSc, being able to provide that portability, the tools that generate the documentation, things like that. If you only have 1 or 2 or 3 people who are good at those pieces, they tend to bog down a little bit, and it becomes, well, we'll have to wait for the expert to come in and fix this problem. And in a fast-moving community like PETSc, you can't wait. You don't want to wait a week for something to work on a new machine. You want it to be working on the new machine the very next day. And so organizing and designing all of the code so that a larger collection of people can work on it, can contribute to it, and understand it is really crucial to maintaining the entire package. We do this very well, I would say, for the actual software. For the configuration code, it's not quite as good. And the documentation, which we're currently now totally revising, will hopefully be organized in a way that many people can understand how the documentation is generated and run, so that anybody can step in and fix the problems that come up. We're not in a position to be able to just say, okay, we're going to hire 2 people who are going to maintain the documentation for the package, or we're going to hire 2 people who manage the configuration. Instead, it has to come from the community, and it always has come that way, where someone would either need to solve a problem and go in and explore and figure out how to solve the problem, or they would talk to other people and understand where the problems are coming from, and as a group, we discuss how the problems could be handled.
Thanks, Barry. So this kind of naturally leads into a question of how do we recruit new people to join our endeavors? Hong, would you have comments about that?
Oh, yeah. My name is Hong Zhang. I joined the PETSc team for almost more than 20 years. I love this team. So among all the activities, one I really enjoy is working with the young people, right? So teaching at a local university, attending the user workshop, and also working with the summer students. For all these years, I do have some experience on how to kind of working with students. And for example, I always start with a careful design of the project, which fits to the students' individual interests and the capability. And also I will start working with them hand by hand in the beginning. And then I encourage them to have their own ideas, and I help them to experiment their ideas. So once they get overcoming the initial learning curve, and then sometimes students can make surprising progress. Some can advance to very far. And I had a few former students even join PETSc team as developers. So what I see is those young people bring the new innovative ideas and the new technology to the PETSc. At the same time, actually, we all got the personal professional growth for me, also for my students. So I feel it's very critical to keep recruiting, like kind of attracting the young people into our team. And we may need to do it in a systematic way. So this is what
Thanks, Hong. Yes, I know you've been really effective in engaging lots of people over the years. Jed, do you have additional comments? I know you're working with lots of students and used to be one
so
also.
Advising students is one form, and it's certainly an important one. Also, we can use PETSc when we teach classes, and students in those classes, they then know how to use it. They go on solving their own problems, and maybe things come along that make sense to contribute into PETSc. We teach tutorials. We spend a lot of time talking with collaborators, students of collaborators. Maybe we notice a presentation or a paper and we're like, hey, I'm gonna go ahead and implement this. And I'll spend some time with the developers of that method. And maybe their follow-on work, when they design better methods, they're gonna do it by adapting and contributing that to PETSc. One of the challenges with students is PhD students are in a department. They're in an applied math department, or they're in an engineering or computer science department. And there are expectations within that department of, say, what does a thesis look like? And having a bunch of code, even if it's documented and it's been peer reviewed in the sense that it's merged into a large project, doesn't necessarily fulfill the expectations of that kind of position. That you can get a thesis on that basis, or that you can advance your career and get an academic position or whatever career you're interested in. And so part of this challenge goes beyond say the technical work that is required and the individual reward. There's also an institutional award and recognition. And so there are projects like the Journal of Open Source Software as a way to provide credit that maybe can exist within the academic system. And but there are many, many facets to this of how do we recognize, not just within our community and our team, but externally, recognize those contributions so that people feel comfortable doing it. Even if they want to do it, they have to kind of meet the expectations of their organizations.
Thanks, Jed. We didn't get a chance to officially introduce Jed earlier, so I'll just mention that he's a professor at University of Colorado Boulder now, but started working with PETSc when he was a student, worked at Argonne as a postdoc, and assistant computer scientist. So he's transitioned across a variety of roles. All right, so let's pivot to another topic. Barry, can you speak about any challenges or ideas that you have for technical approaches, tools, processes that could help to improve how the software team does its work?
In the last couple of years, we've made some fairly dramatic changes to how we manage our source code development. We've switched to GitLab, and we're using the GitLab CI infrastructure for continuous integration. Overall, I would say we're quite happy with it. There's a couple of things that are at times frustrating and time consuming. GitLab is actually growing dramatically. They add new features to their software regularly. So it's a very dynamic community itself, which I think is great, but there are some missing pieces. For example, GitLab currently will not automatically assign reviewers based on the source code changes in the MR, even though there is part of the infrastructure available to do that in their software. And this means that when someone submits an MR, they have to know who should be the appropriate reviewers, which of course they generally will not know, which means that someone else may have to go into the MR and add the appropriate reviewers, spending their valuable time doing that. Another issue that comes up a bit is with the tests on rather obscure systems. We pride ourselves in PETSc's portability. So for example, we test with various compilers that are only used in a small number of sites. And these compilers are great because they find things the other compilers do not find, but it's also the compilers may only work under certain operating systems and so forth. They're not something that everybody has access to. So it is sometimes inconvenient when a developer has to spend a few hours trying to determine the problem on one of our CI test machines that are not easy to access or easy to use because they're not intended really for development work. They're just set up for testing purposes. And it would be nice to make that workflow a little easier. It generally falls on a very small number of people who have gotten used to these machines to do this type of portability fixes. And it would be much better if each of the developers could have access to the systems in a way that was convenient to them to do this type of thing. And with the movement now towards GPUs, we're going to see more of this because not everybody is going to have access to all of the major vendors' GPUs. And when their code goes wrong on a particular system, they're still going to need a way to access such a system to debug the problem and find fixes and then fix their MR for that system.
Yeah, it's a really good point. Matt, do you have additional comments? I know you think a lot about tools.
I guess I didn't, my main gripe has always been that many of our tests are regression based. So we verify that the certain output doesn't change. And it would be nice to move to tests that have more automated verification. And that's an analytic issue. And it works well in some cases, like PDEs are much easier to get at in this sense, but say the linear algebra is more difficult. I mean, I guess you could kind of conceive of cases where you know the result because the matrix has a certain form, but that doesn't get these kind of random structure errors that you get. I mean, how are you going to verify parallel sparse matrix, which would be something that we would like to do. I guess I would like to see us do the same kind of verification for performance models too, that we don't do. Performance regression is a lot harder to catch, and it happens, and it's happened to us. And I would like to be able to catch performance regression by having our tests verify the performance model. And we don't often do this. I have a few tests that do this for the mesh stuff, but I don't have anything that does it, for instance, for a full PDE solve or anything like that.
Yeah, testing is really important. Well, as we're winding down this interview, I'd like just to conclude by talking about any cultural issues that the team might want to bring up. I know there's a lot of complexity here. Richard, do you have comments on this front?
Yeah, I had an issue that I'm not sure if it's quite a cultural issue, but you know, something that was really important to me when I started using PETSc was the very responsive and consistently helpful support through the PETSc mailing lists. You know, I started using PETSc as a graduate student, writing a pretty complicated simulation code using very immature at the time Fortran interfaces in PETSc, and a lot of stuff was broken, right? And Barry and Matt in particular were extremely helpful to this grad student. They didn't know doing this. And you know, through the years, Barry and Matt and Jed and Satish Pillai, who's not on the call, particularly have all answered a huge amount of these you know, emails to the PETSc user support forums. It's something that I think PETSc's done a fantastic job with, but I do just kind of note that the keeping up with this is really hard, especially as the PETSc user base has grown. And right now there's sort of a very imbalanced set of people who really answer the bulk of these email messages. You know, like I once in a blue moon, I answer one, but I mostly just feel guilty that I don't have time to get to answer a bunch of them. And right now, just a few people like Barry have been, you know, heroically shouldering a huge load to do this, and I just kind of worry about for the future how's a way that we can, you know, support users with this great responsive support, but you know, involve more people. And I'm not really sure what the answers are.
Good question.
I would like to add a little bit to Richard's comment. With PETSc, we've always considered all users equal in terms of the need for support. And as a bottom-up community, we can do that because that we do receive funding for various projects. And of course, those projects need to be done and do get done. When we speak about users, we don't have a hierarchy of types of users, whether it's a graduate student or an undergraduate just starting out, or it's someone who's been using PETSc for 20 years who has a more advanced question. They all go into the same queue, and we try to respond and be responsive to them in the same way, irregardless of where they may be in their history and and their relative importance. So in a sense, they're all our neighbors. And when our neighbors need help, we go and help our neighbors. We don't say, you live in the $1 million house, so we're going to help you more than you live in a smaller house. Another thing that is important is that because we don't really know who's important, we don't know who's going to be important. When I responded to the first email from Matt many, many years ago, I had no idea how much he would contribute to the PETSc community over the years. And similarly for many other people. Almost everybody, not almost everybody actually, everybody begins as a beginner. And so the most important people are really the beginners, and how we treat the beginners and how we help the beginners, because they're the ones who need the help the most. And they are the ones who in the long run will contribute the most as they develop their skills and their knowledge. And they begin to not only help with PETSc, but in fact, drive large parts of PETSc and determine where it's going and contribute to it.
Thanks, Barry. That's an important perspective. Hong, do you have additional comments?
Oh, you're muted, Hong.
Well, I agree with Barry. So what the very impressive part is we answer all the emails. And whenever I go out to give tutorial talk, right, people will ask me, like, who is your competitor? I cannot say that part, but at least I say PETSc is very unique. Everyone, whenever you send an email, disregard your undergraduate student, you ask for stupid questions, we answer every email in time, right? Usually in minutes or hours. So this is a very unique feature of the PETSc.
Thanks, Hong. Any other comments about culture? I know Jed and Hong, you both have been thinking about these points more broadly. Hong?
Yeah, I can talk about culture. I love the team. Yeah, I work in this team for 20 years. I still really enjoy it. I feel it's like a family, right? 3 things I like the most. One is it gave me tremendous freedom to do the projects I'm passionate about. And also I can work with very diversified collaborators, the users. And the third is the PETSc team is very supportive. No one knows everything. So whenever I need help, I can go to like someone knows GPU, someone knows how to build the PETSc library on supercomputers. I always get the support. So that's how to keep project going. And I do the same thing for others at the same way. So this is what I love. The other is about the culture. So we all have families, we have kids, right? And the children may have different issues. So whenever I need to be home, and Barry or whoever in charge, they always say, yeah, just leave. And I have a very much like the trust from everyone. And this is what I love the most.
Thanks, Hong. That's been important to me too. Jed, any concluding comments?
Yeah, so I've been a user since 2004 and a developer since 2008. And over that period of time, I've gone through phases of my life and been able to contribute in different ways. And the PETSc community has been really important to me throughout that. And I feel like the kinds of contributions that I can make, yeah, those have changed, but they're still recognized. I think when we look at our community, it is not as diverse as it could be. And I think that there is more work we can do to recognize who's being left out of this club in a sense, and why have we not built a community that has more diversity? And at an individual level of like, yeah, you write to the list, we're going to welcome you there and do our best to reply and whatnot. But I think we can be more proactive as a community. And I think that's where a lot of our opportunities lie over the coming years of how can we recognize better the implicit structures in which we operate and where we may be overlooking people who can be tomorrow's contributors.
So when you say community, do you think there's stuff specifically that we can do at the PETSc layer, or does it all have to be done at a higher structural from a viewpoint?
It's both and all at the same time. But I think there are things that can be done at every level.
Okay.
Yeah.
And
Good food for thought. I'm sure that people watching this recording will have really interesting thoughts from their own perspectives too. Well, I just want to close by thanking all the people who spoke with us today. Thank all of the users and other developers who couldn't be with us today. And thank all the developers of lots of other software out there. So we look forward to continuing these discussions in that broader context. Thank you.